Hello everyone. In today's LeetCode problem, we are looking at the minimum time to make a rope colorful. So what is meant by that? Let's look at the example picture below here. So we are giving a rope of balloons, and what we need to do is we need to make sure that any two consecutive balloons do have different colors. So if you look at the first balloons here, we have no problem, or the last balloon, but this segment with the two balloons is actually a problem because we want to have them to be different colors. So how can we achieve this? Well, we cannot change the colors of balloons, but we have our friend Bob, and Bob can pop balloons actually to remove those that are offending. And so in this case, we ask Bob to pop the third balloon on the row, and by this we now get a rope where all of the consecutive balloons have actually different colors as we want. So now Bob doesn't do this for free, so there's a cost in time that Bob needs to pop the balloons, and this cost is actually different for each balloon. So in the example here, the costs are 1, 2, 3, 4, 5. So we can either pop the balloon with cost 3 or pop the balloon with cost 4. And of course we want to minimize our cost. So we decide here to let Bob pop the balloon with cost 3. Okay, let's look at a larger example now. So let's look at the longest sequence of balloons, and we'll have the colors here. And let's say the first one is red, and then we have 4 blue balloons. 1, 2, 3, 4, and then 1 green one. And now what about the costs? So let's assign some costs for Bob. 6, 2, 9, 4, 8. Okay. So, and we already know that this red balloon and this green balloon, they are not really interesting because they are single balloons, so we do not need to pop them at all. So what about the blue balloons? So now we know that we may keep only one blue balloon in this segment, so we must pop all but one of them. So now we could ask ourselves, which of the balloons should we keep? And since we want to minimize the cost, we want to keep this blue balloon because it has the highest cost of 9. And all of the other balloons can be popped to minimize the cost. So how can we do this in the most efficient way possible? Let's say we go over the balloons from left to right once, and we want to decide which balloons to pop. And we can do it by, for these longer segments, basically, what we want to do is, we want to keep track of the highest balloon that we found so far, because this one we are not going to pop. So let's call this maybe high. And for the red balloon, it's 1, okay. And then we go to the blue balloons, so we reset our high balloon and we say, okay, here 6 is the high balloon. So then we see 2, which is not higher than 6, so still 6 is our high balloon. And then we see a 9, so now 9 becomes our high balloon. And then we see 4, which is smaller than 9, so still 9 is our high balloon. And now we come to the green segment, so the blue segment is over. And now we know that, okay, for the green segment we reset high again. So let's say here we reset, and also here we reset. And now we know that the most expensive blue balloon has the cost 9. So this is the one we do not want to pop. But what about the ones that we want to pop? Well, we also need to know the sum of all the balloons which are not high. So let's also keep track of that and say the sum of each segment. So for the red balloon is 1, but it doesn't matter. Then here we reset. And then the sum is 6. 8 plus 9 is 17. Plus 4 is 21. Then we reset. And then we have 8. Okay. And now, basically, for what will be the cost of popping all of the balloons except the high one, it will be sum minus high. So in this case, the sum is 21 and the high is 9. So we have a total cost of 12 for popping the blue balloons. Let's check that. So the balloons that we pop have cost 6, 2 and 4. So actually that makes sense because this 12 can be written as 6 plus 2 plus 4. Okay. So basically that's the algorithm that we're going to use. We go over the balloons from left to right. For each segment that has the same color, we keep track of the highest balloon and the total sum of all the costs. And in the end, what we need to compute is sum minus high. And now actually this also works for the segments that have only one balloon. For example, for the red balloon here, high is 1 and sum is 1. So we will calculate a cost of 0, which is fine. So we can use the same technique both for the segments with one balloon and for the segments with more than one balloon. Now there's one technicality here because at the end we have basically a last segment which we also need to take care of. So basically at the end we might maybe reset again and then also handle the last segment. And to make this a bit easier in implementation, we can use a nice trick here. We can use a sentinel element. So at the very end of the color array we might add like a fake color star, which is not one of all the other colors, as a sentinel. And then basically when we go over the end of the normal balloons to the sentinel, we can treat this last segment like all the previous segments as well without needing any special logic. Okay, then let's head to the implementation. Okay, let's go over the code of the solution. So as described, first we are adding the sentinel element at the back of the array. So we added both to the color string. So here I added the star color at the end. And also for the bob array, I added a cost of 0 to remove the sentinel. But anyway, the sentinel will never be popped because it is the single balloon with that color. And then we initialize the high and sum variable and also a variable that shall contain the answer in the end. And then we make a linear pass over all of the balloons. And basically first here we have some logic to handle the switch from one color to the next color. So if we are not at the very first balloon and the color of the current balloon is different from the color of the last balloon, then we are at the position where we're making the switch. And now in this case we must first finish the segment that we had previously. So we increase the answer by sum minus high, as we saw in the explanation. And then we reset both the high balloon and the sum of the balloons because we are now starting a new segment. And what we do now for each balloon, we get the current cost of bob, and then we update the high and the sum variable, where of course for high we take the maximum and for sum we just add the current cost. And after we finished looping over all of the balloons, including the sentinel, we can return the answer. So that's the solution for problem 1578. I hope you liked the video. If you liked it, please give it a like. and consider subscribing to the channel, and see you in the next one. Bye.